GPT-5 just scored 29% higher than human medical experts on complex diagnostic questions involving both text and medical images. Meanwhile, Tesla completely scrapped their VR-based robot training system and switched to something that sounds straight out of science fiction, training humanoid robots by watching videos just like their self-driving cars. But here's the kicker. Hyundai just committed $26 billion to build a robotics facility that will pump out 30,000 robots annually. And Time magazine named a Cloudflare co-founder the most important person in AI for 2025. Not Elon Musk, not Sam Altman, someone you've probably never heard of. Welcome to the AI and robotics landscape of 2025, where medical AI is surpassing human experts, robots are learning like humans do, and the real power players aren't who you think they are. Let's start with what might be the most significant AI advancement this year, GPT-5's performance on medical licensing exams. We're not talking about slight improvements here. This is a fundamental leap in AI's ability to understand and reason about complex medical scenarios. GPT-5 was tested on medical licensing questions from the US, China, and Taiwan, including multiple-choice questions, text-based scenarios, and critically, questions involving medical images and radiology scans. Against GPT-4, the results were impressive but not shocking, 4 to 5% higher accuracy on text-based questions. But when it came to questions involving both visual and textual analysis, the kind of complex multimodal reasoning that's always been challenging for AI, GPT-5 showed up to 30% improvement over its predecessor. Now here's where it gets really interesting. When compared to human medical experts, GPT-5 was 15% more accurate on text-based questions and 24 to 29% more accurate on questions requiring both visual and textual analysis. I have to be honest, when I first read these numbers, I was skeptical. Medical expertise isn't just about pattern recognition. It's about understanding context, making judgment calls, and dealing with ambiguous information. But the fact that GPT-5 is outperforming on the multimodal questions, where you need to analyze X-rays, MRIs, and patient histories simultaneously, suggests something more profound than just better pattern matching. This doesn't mean GPT-5 should replace doctors, but it could revolutionize medical education, serve as a diagnostic aid, and provide medical information access in underserved areas. The question is whether healthcare systems will adapt quickly enough to leverage these capabilities responsibly. Now, let's talk about Tesla's Optimus robot, because they just made a change that could accelerate humanoid robot deployment by years. Previously, Tesla was training Optimus using human instructors wearing VR headsets and motion capture suits. Humans would physically demonstrate movements, and the robot would learn to mimic them. It sounds logical, but it was slow, expensive, and limited by how many human demonstrations you could collect. Tesla scrapped that entire approach. Now they're training Optimus using videos, the same way they train their autonomous driving software using camera data from millions of Tesla vehicles. Think about the implications. Instead of needing human demonstrators for every possible task, Optimus can learn from virtually unlimited video data. YouTube alone contains millions of hours of humans performing every conceivable task. The robot can observe how humans navigate dynamic environments, react to unexpected situations, and adapt to changing conditions. This shift is driven by Elon Musk's ambitious goal of producing 5,000 Optimus robots annually by 2024-2025. The old training method simply couldn't scale to meet those production targets. But here's where I get a bit skeptical. Video-based learning works well for Tesla's cars because driving, while complex, follows relatively predictable patterns. Roads have rules, traffic behaves somewhat predictably, and the environment is structured. Humanoid robots in homes and workplaces face much more chaotic, unstructured environments. A robot might need to navigate around a toddler's toys, adapt to different furniture layouts, or handle delicate objects with varying materials and weights. I'm curious whether video-based training can capture the full complexity of these scenarios. While Tesla is innovating in training methods, Hyundai is making a massive infrastructure bet. The automotive giant, which owns a majority stake in Boston Dynamics, just announced a $26 billion investment in U.S. operations by 2028, with $5 billion specifically allocated to a robotics manufacturing facility. This facility isn't just a factory. It's designed as a complete robotics innovation center covering design, production, testing, and distribution. The goal is to produce 30,000 robots annually, which would make it one of the largest robotics production facilities in the world. What I find strategic about Hyundai's approach is the integration with their automotive expertise. Both cars and robots involve developing intelligent mobile systems that need to navigate complex environments. The synergies between autonomous vehicles and humanoid robotics are becoming clearer as both technologies mature. The decision to locate this facility in the U.S. is also significant from a geopolitical perspective. With increasing tensions around technology supply chains, having domestic robotics production capacity becomes strategically important. But 30,000 robots annually raises questions about market demand. Are there really enough use cases for humanoid robots to justify that level of production? I think Hyundai is betting on applications we haven't fully envisioned yet, particularly in manufacturing, logistics, and elder care as populations age globally. Time Magazine's 2025 list of most important people in AI reveals something fascinating about where real power lies in the AI ecosystem. The top spot didn't go to Elon Musk or Sam Altman, it went to Matthew Prince, co-founder of Cloudflare. Most people have never heard of Prince, but Cloudflare handles about 1/5 of all internet traffic. That gives Prince unprecedented influence over how AI companies access training data. Prince has introduced a pay-per-crawl model that allows content creators to license their content to AI companies for training purposes. This addresses a major issue in AI development, the fact that models are trained on vast amounts of content without compensating the original creators. Here's why this matters more than flashy AI demos. AI companies need massive amounts of high-quality data to train their models. If content creators can control access to their content and get paid for it, that fundamentally changes the economics of AI development. We're already seeing the impact. With AI overviews and search engines providing direct answers, users are less likely to click through to original sources. Content creators and news websites are seeing significant traffic declines. Prince's licensing model could help creators monetize their content in this new AI-dominated landscape. Prince predicts the next 30 years will be the AI era, following the previous 30 years of the search engine era. If he's right, controlling access to training data makes him more powerful than most AI company CEOs. Speaking of training data, we're seeing significant shifts in how AI companies approach data collection and privacy. Anthropic announced that starting September 28, 2025, they'll use user conversations with Claude for model training unless users manually opt out. This represents a broader trend toward using real user interactions to improve AI models rather than relying solely on static datasets. It makes sense from a technical perspective. Real conversations provide more diverse, natural examples of how humans actually communicate. But it also raises privacy concerns that the industry is still figuring out. Most users probably aren't aware their conversations are being used for training, and opt-out systems typically result in very few people actually opting out. Meanwhile, OpenAI launched a new voice generation API supporting 57 languages, including Turkish. The quality is reportedly nearly indistinguishable from human speech, positioning it as a direct competitor to services like 11 Labs. Microsoft is also making moves toward independence from OpenAI, releasing their own AI models called Mai under DeepMind co-founder Mustafa Suleyman's leadership. This suggests potential tensions between Microsoft and OpenAI over the future direction of AI development. AI-generated video content is becoming increasingly sophisticated and accessible. Tools like HeyGen allow users to create professional-looking videos by selecting avatars, customizing voices, and inputting scripts. The process has become surprisingly straightforward. Choose a video style, pick an avatar from pre-existing options, a photo avatar created from a single image, or a digital twin from a 2 to 5 minute video. Users can record their own voice, clone it, or import voices from third-party services. HeyGen's pricing reflects the mainstream push. Free tier includes 3 videos monthly at 720p. Paid tiers start at $29 a month for unlimited videos up to 30 minutes at 1080p, and $39 a month for 4K output. What strikes me about these tools is how they're democratizing video production. Creating professional-looking content that once required expensive equipment and expertise can now be done by anyone with a computer and an internet connection. But this also accelerates concerns about deepfakes and misinformation. As the technology becomes more accessible and realistic, distinguishing between authentic and AI-generated content becomes increasingly difficult. If you liked this video, don't forget to hit the like button, comment with your thoughts on whether AI should surpass human medical experts, and subscribe to the channel for more AI and robotics insights. Looking at these developments together, several larger trends emerge. First, AI is moving from experimental technology to practical tools that outperform humans in specific domains. GPT-5's medical performance suggests we're approaching human-level or better AI in knowledge-intensive fields. Second, the robotics industry is shifting from laboratory demonstrations to serious production planning. Tesla's training revolution and Hyundai's massive facility investment suggest we're approaching commercial viability for humanoid robots. Third, the AI ecosystem is becoming more complex and interdependent. The content creators who provide training data, the infrastructure companies that control data access, and the hardware manufacturers enabling AI deployment are all gaining strategic importance. Fourth, geopolitical considerations are increasingly shaping AI and robotics development. Hyundai's decision to build in the US, Microsoft's move toward independence from OpenAI, and the broader concerns about supply chain security all reflect the strategic nature of these technologies. The convergence of advanced AI capabilities, scalable robotics production, and new business models for data licensing suggests we're entering a new phase of technological development. In healthcare, AI assistants that surpass human diagnostic capabilities could revolutionize medical education and patient care, particularly in regions with limited access to specialists. In robotics, the combination of improved training methods and large-scale production facilities could finally make humanoid robots economically viable for a range of applications beyond manufacturing. In content creation, AI tools that can generate realistic videos, voices, and text are lowering barriers to entry while raising new questions about authenticity and intellectual property. But several challenges remain. The technical capabilities exist, but social acceptance, regulatory frameworks, and economic models are still evolving. The gap between what's possible in controlled environments and what works reliably in the real world remains significant. Based on these developments, here's my honest assessment of what we can expect. Medical AI will likely become standard diagnostic aids within 2 to 3 years, but regulatory approval processes will slow deployment. Don't expect AI doctors, but do expect AI-assisted healthcare. Humanoid robots will probably see limited commercial deployment in specialized applications like elder care and hazardous environments within 3 to 5 years. Mass market adoption for household applications is still probably 5 to 10 years away. AI-generated content will continue improving rapidly, but the authenticity verification challenge will intensify. We'll likely see new tools and standards for identifying AI-generated content. The data licensing model that Matthew Prince is pioneering could reshape how AI companies access training data, potentially slowing down model development, but creating fairer compensation for content creators. What's clear is that the pace of AI and robotics development continues accelerating. The gap between laboratory capabilities and real-world applications is narrowing, production is scaling up, and business models are evolving to support sustainable development. But we're also seeing the emergence of new challenges, ensuring AI safety and reliability, managing the economic disruption of automation, protecting privacy and intellectual property, and navigating the geopolitical implications of these technologies. The companies and individuals who figure out these challenges alongside the technical development will shape the next decade of human-machine interaction. Based on Time magazine's rankings, some of the most influential people might not be the ones getting the most media attention. GPT-5's medical performance suggests AI capabilities are advancing faster than many predicted. Tesla's robot training revolution indicates deployment timelines might be shorter than expected.
Hyundai's massive investment shows established companies are betting big on robotics becoming mainstream. Whether these bets pay off depends not just on the technology continuing to improve, but on society's ability to adapt to the rapid changes ahead. The next few years will be crucial for determining whether these advances become transformative tools or just impressive demonstrations. One thing is certain, the AI and robotics landscape of 2025 already looks dramatically different from what most people expected even 2 years ago. The acceleration is real, the applications are becoming practical, and the implications are only beginning to unfold.